Good evening. My name is Rupa Parekh. I'm going to present security issues in big data analytics. My use case: I work for defense and aerospace industry. Before even thinking about using big data analytics, our first question comes is it safe to use it? That made it a requirement for me to take this topic as a project work for CSCI 185. So basics of information security. When you talk about information security, few things come in mind. First is authentication. So anybody who is having an access of the system should have a authentication requirement to have a user ID and password management should be very critical. Create easy to remember, hard to guess passwords so that you don't lose security by just giving away passwords. Second thing is authorization or access control. So if there are multiple users coming to the system, some might have limited access, some might have a lot of access, like admins might have a lot of access versus other application users might not. Third thing comes into mind is when you put a system on a network, network security is crucial, and typically used phenomena are firewalls and access control lists, and we all use them, and we all know that they work up to a certain extent. They definitely don't work when the threats are coming within the firewall, and most security breaches happen from inside the firewall. So the next level of defense come into mind, which is secure the information itself, which is done by cryptography. There are a lot of known techniques for it, and I'm sure most of you are aware of it. And last but not least is to educate the users who is using the system. If they're aware of the security breaches, then they would reduce the security incidents. Like for example, if you're um, getting something from web or downloading information from web, if you don't know the source of the information, then that download could be malicious, things like that. So security in conventional DBMSs, why am I talking about this? Because this will give us an idea on how big data analytics is different when it comes to security than the conventional DBMS. So conventional database systems typically have a single copy of data wrapped in various protection until it's processed. It also offers role-based access control like roles, groups, schemas, label security. The data is protected. Not only data is protected, but the data dictionary is usually protected. Not everybody has access to it. So I can just go one day there and or um, remove or delete parts of the data dictionary and make the DBMS malfunction. Limited access to underlying operating system is a usual security consideration in DBMS system, so that when DBMS is storing a data on files on underlying operating system, you don't typically have access to those files, so you can't just remove those files so that your database system would malfunction. And then encryption of sensitive data is common. Also, taking backup on different media is normal usage of DBMS, but at the same time, encryption of it is also quite common. So knowing that, let's compare it with security issues with big data analytics, how it's different than the conventional data analytics. Typically, big data analytics is done in distributed environment. We all know it. We did few assignments on this. Multiple nodes are running across the network to process chunk of data in parallel. So data replication on multiple node is done to support fail-safe operations. So if one of the node is down, the second or other one can take over it. That makes it difficult to know which data is located where and to give access control. Secure communication on multiple nodes become crucial at that point. It does have schema level access control, but it doesn't have as good a granularity as the conventional DBMS offers. Big data analytics is elastic in nature, so clusters are open and self-organizing. Clusters allow users to communicate to multiple nodes simultaneously, which makes restricting access to certain data nodes by certain client only to have access to information becomes a little tricky. So this is how it differs from conventional database management. Now, when the big data analytics comes into mind, first product comes into mind is Hadoop, and is Hadoop secure? So whatever I'm going to talk about Hadoop security assumes that Hadoop's current threat model assumes that you do not have access, or you do not have root access to cluster machines. You do not have root access to shared client machines. If you have that, none of the security model is going to work because you are the super user. And also, it also assumes that read or modifying packets on the network of a cluster is not possible. So it assumes that you have some sort of encryption or network security taken care of there. So keeping that in mind, security with Hadoop, and Hadoop is secure or not. So when I started looking at apache.hadoop.org, it does talk about authentication and authorization, the two basics of security. It offers service level authorization. Service level authorization is the initial authorization mechanism to ensure clients connecting to a particular Hadoop service have the necessary pre-configured permissions and are authorized to access the given service. So it is providing service level authorization. It does provide some authentication. Now, when you and I did the homeworks, if you remember when we brought up the web console for name node or data node using that 50070 and 50030 node, there was no authentication required there. But if you configure it, it is available. But then the question remains, what happens to data at rest in HDFS? Just like we talked in RDBMS, that database management system makes sure that you don't have access to those files underlying operating system. What happens to the files in HDFS? And files and directory permissions do not provide enough security. It just provides incidental error. It prevents you to delete from deleting some files accidentally, but it does not really provide any authentication. So that's a key for protecting HDFS. How about secure map task? Like when you submit your own MapReduce task, and if somebody else on the same cluster submits the MapReduce task, you both are under the same user. So I can delete somebody else's task because they are all running under one user. So authentication is a key here, and I could not find any answer on apache.hadoop.org for that. So what happens to data on network within cluster? I couldn't find much of an answer for that either. So I thought of one step further. I thought of Cloudera CDH4 implementation, because we used it in our homeworks, and Cloudera looks like provides a very good environment for running Hadoop or many other tools which do work around Hadoop to create the big data ecosystem. So I started looking into the security within the Cloudera, and to my surprise, Cloudera CDH4 offers Kerberos security on CDH4 cluster. What does that mean? That means that it offers Hadoop daemons leverage. It offers security such a way that the Hadoop daemons leverage Kerberos protocol to perform user authentication on remote procedure calls. So now you have each RPCs having authentication with the username and password, which sounds like a promising thing. And then group resolution is performed on Hadoop master node, name node, job tracker, and resource manager. So there is more granularity than what I read on Hadoop's documentation. Map tasks are run on the user account who submitted the job, providing the isolation. So as I talked earlier, that if I am running MapReduce task and one of my friend is running MapReduce task, now we both have access control on it. So I can't remove his task by accidentally, or he can't do mine. New authorization mechanisms have been introduced to HDFS and MapReduce to have access control on data itself. So now, when your data is at rest, at that time also, there is an access control on it. So you can't just go ahead and remove some HDFS files by accident or maliciously without having correct authorization. Same thing with the MapReduce jobs. So CDH 4.1.0 supports encryption of all user data sent over the network. So that is another base for our security 101, that the network data over network is secured. So what is Kerberos? We talked about Kerberos protocol, and I wanted to talk a little bit about it. It's a network authentication protocol developed by MIT, Massachusetts Institute of Technology, uses secret key encryption or cryptography for client-server application. I read upon this, and it looks like a lot of people are warning that it's a little bit tough to configure. So even though CDH4 is offering it, unless you really configure it correctly, it might not work the way it's claiming to be. And then after client and server uses Kerberos to establish their identity, this protocol allows the encryption of all the communication to assure privacy and data integrity. That's the basis of Kerberos and Kerberos protocol. And if you want to read more about it, the great reference found is web.mit.edu Kerberos, and it talks much more in detail how things work with this protocol. So let's talk about taking CDH4 security setup and implementing it. So the Cloudera security guide talks in detail in 15 different steps how this can be configured. I'm not going to go into each step in detail because in limited time I cannot provide all the details, but these are the basic steps they are listing, and all the details are provided in the link. 2 slides back I have provided the security guide link for the Cloudera. So once we install CDH4, we have to verify certain user accounts. One of the user accounts we had set up was HDFS Unix account, and there is another one they're trying to verify. And then at step 3, if you are using AES-256 encryption, install the JCE policy file. So since we used CentOS 6.4, CentOS 6 and onwards uses this AES-256 encryption. So we have to install that JCE policy file and then create and deploy the Kerberos principles and key tab files. We have to follow that closely. As I said, a lot of people warn that if it's not configured correctly at that point, it might not secure correctly. And then shut down the cluster, enable Hadoop security by configuring core-site.xml and configure secure HDFS in HDFS site.xml. These 2 files reside in /etc/Hadoop/conf directory. And then optional setup 8 is to configure security for HDFS high availability. Then another optional setup is to configure secure web HDFS if you are using it, and then set variables for secure data nodes and /etc default Hadoop HDFS data node, and then start up the name node and data node and set the sticky bit on. Start up the secondary name node if used, and then configure either MRV1 security or YARN security. And there, again, the step-by-step information can be found on CDH4 security guide.pdf. I have given the URL here. So in short, the takeaway from this is CDH4 has promising security model for Hadoop. It covers all the basic security 101 elements we saw on slide 1, which is authentication, authorization, network security, data encryption, and so on. CDH4 also provides Kerberos security model for other components for big data ecosystem like Flume, Hue, or Oozie, HTTPFS, HBase, Hive, HCatalog, and Zookeeper, and so on. So in a nutshell, CDH4 looks like having a good security model to start with. I'm going to explore it, and thank you so much for listening to me. I really enjoy working with all of you on this course. Have a very good evening.